A ball is thrown from the top of a cliff at 15 meters per second at an angle of 30 degrees above the horizontal. The cliff is 20 meters above the sea. Find the greatest height above the sea reached by the ball. So let's have a look at that first. So I've already drawn the diagram over here. There's my cliff. It's been thrown at 30 degrees above the horizontal, and it's thrown at 15 meters per second to start off with. So let's label that. And we've got sort of 30 degrees in there, and this height is 20 meters, and the question is find the greatest height above the sea reached by the ball. So that's going to be this height here. Okay, at that height we know the velocity, the vertical velocity, is 0. So let's write down both directions first of all though. So kinematics of the ball, S, U, V, A and T. In a horizontal sense there is no acceleration because there are no forces. We know that the initial velocity is going to be 15 cos 30, and 15 cos 30 we could work out as root 3 over 2, we can work that out later. But we know because there's no acceleration, the final velocity is also 15 cos 30. In fact, it's just 15 cos 30 the whole way along. And we don't know S or T. In a vertical motion of the ball, we know S, U, V, A and T. We know the acceleration is always minus G. And we know this is 15 sine 30. Now 15 sine 30 is going to be 7.5, so let's put that in as 7.5 straight away. And for the first question, the question is asking to find the greatest height above the sea reached by the ball. So we know that at that point the velocity in a vertical sense is 0, and we want to work out S. So an equation without a t in it is going to be v squared equals u squared plus 2as. V squared equals u squared plus 2as. V is equal to 0. U squared is 7/8 are 56.25. So 7.5 squared, let's just write in 7.5 squared. 2 acceleration is minus 19.6, so 2g, and then s, and that means that s is just 7.5 squared divided by 19.6. 7.5 squared is 56.25. Divide that by 19.6, and we get an answer of 2.87. 2.87. In fact, let's just put, because I want to answer this question to 3 significant figures, and I know that I'm going to put 20 meters on this in a second. I've got to be a little bit careful that I don't round up twice. So let me just truncate this rather than round it and put 2.869. Okay. In this case, it didn't matter, but I just want to be careful that I don't round twice. So I can put therefore. I'm not going to say S equals 22.869 because S is displacement. I'm going to write, as the question is worded, the greatest height equals 22 point, and the 6 rounds up to 9 meters. And let me just store that as A on my calculator just in case I need that for later on. Okay, question 2, or part B. The distance between the bottom of the cliff and the point where the ball enters the sea. Okay, so that's from here to here. So we're looking at the motion of the journey from here all the way to here. So now V is no longer 0, but we do know that the overall displacement is negative 20. And the question we're asked is what is S in the horizontal sense. So you might think that, oh look, I've got 3 unknowns and I'll try and find S, I can use one of my smooth out equations straight away. But actually, if you use something like equation without a t, v squared equals u squared plus 2as, you get this squared equals this squared plus 0s. So you just get this squared equals this squared, which we already know. So we can't use that. We need to work out the t and then use t, a, and either u or v to work out s. And the thing that links it here is that the t in the vertical motion is the same as in the horizontal motion. So s, u, a, and t, I want an equation without a v. That's going to be s equals ut plus a half at squared. S is going to equal minus 20. U is 7.5 t. A is minus 4.9 t squared. So let's get everything over to the left hand side, and I'm going to times through by 10 just to make these numbers nice. So it's 49t squared, take away 75t, take away 200. Let me just check that's right. 49t squared, 75 there. Yep, okay. Let me just solve that equation, and you should all know how to use this with your calculator. It's probably the quickest way in an exam. Menu A, sorry, menu of press shift, menu A, polynomial 2 degrees, that's going to be 49 minus 75 and minus 200, and I get solutions of t equals 2.93 seconds, and I'm going to store that in my B just in case I need it later on. I'm not too sure. And if I press equals again, I also get an answer of minus 1.39 or minus 1.40. This one doesn't count though. So why is, let's talk about that for a little second. Why is our equation telling us that there's a solution at negative 1.4? Well, your equation doesn't know that there's cliff, and it doesn't know that the ball is thrown here. It just knows that the velocity is 15 at this point. So your equation knows it does this, and it's just making a parabola, and it doesn't know that the motion started here. It just knows that it was 15 at this point. So it knows that at 2.93 seconds it was here, and negative 1.4 seconds before the ball was thrown, the ball was essentially in the cliff somewhere here, but at sea level. But it's obviously a false error, a false answer, and we are cleverer than the equation, so rule that one out. And then let's have a look at parts. I know part B still, we need to find the distance between the bottom of the cliff. So now that I know that t is 2.93, I can transfer that across to here, and now I can just use any one of my equations. I will probably use s equals ut plus a half at squared. The acceleration is 0, so my s is just going to equal 15 cos 30 times by 2.93. Now I stored 2.93. If I go back to menu, I stored 2.93 in B, didn't I? Yep. So all I need to do is do 15 times by cos 30 times by B, which gets me 38 meters. Okay, and it's a significant figure, so make sure you put that 0, otherwise you'll lose a mark there. Okay, and on to the final part of the question, part C. The direction of the ball as it is moving with greatest speed. Okay, so we need to be thinking, where is the greatest speed of this ball? Well, in the horizontal sense, the speed doesn't change because there's no acceleration. So it doesn't matter where we take the ball, the horizontal speed is always going to be the same. So we're actually looking for where is the maximum vertical speed. And so you can just imagine this ball being thrown straight up in the air and falling down. The fastest that's going to be is when it hits the sea, okay? Because it's going to have the same speed here as it does here. Okay, the same speed there as it does there. At the top it's going to have speed 0, and it's gaining speed all the time in that direction because the acceleration is 9.8 in that direction. So the fastest speed is going to be here. So we want to find the speed and the direction at which it hits the sea. So I'm going to use my 2.93 now to work out this v, put it together with this, and I can work out the speed, the direction of the ball as it's moving with greatest speed. So let's just look at, let's just do v equals u plus at for this part of the question. V equals u plus at. V is what we're trying to work out. No, this is v of y, I'll put that in now. 7.5 take away 9.8 times by 2.93. So I've got 7.5 take away 9.8 times by, I stored it as b in my calculator, so I'm getting a speed of 21.17. So now I have a speed of, as it's going into the sea, 15 cos 30 and 21.17. So that is the velocity vector there, and I want to work out the velocity vector, so I'm going to work out theta and just say that that's the angle below the horizontal. So let's just quickly work that out there. Theta equals 21.17 over 15 cos 30. Now be careful here because I've got a negative here. If I leave that negative here, I'm going to get a different angle, so I need to times that by -1 to make sure I've got 21.17. Divide by 15 cos 30, and then inverse tan of my answer gets me 58.4 degrees. 58.5 if it's rounded. So therefore the direction of the ball as it is moving with the greatest speed is 58.5 degrees below the horizontal. Perfect.